Hello everyone, this video is for Algebra 2 for your first introduction to radians. Radians is just a different way of measuring an angle, kind of like 32 degrees Fahrenheit is the same as 0 degrees Celsius. Okay, it's just a different way of measuring exactly the same thing. It's a different scale. Okay, so here it goes. The definition of an angle measured in radians is S divided by R. S is the arc length that an angle would cut off if you were to place the thing on a circle. So going from the center of the circle, that's the angle. It's your arc length divided by your radius. That's all the definition is. So say, for example, you're told your radius is 40 centimeters and your angle is 3 pi over 4. You could be asked to find the length of the arc. That it's just you're going to find one of these pieces. So, for example, theta equals S over R, fill in what you know. So you got 40 centimeters down here, and theta is equal to 3 pi over 4. And you're looking in this case for S, because S is the only piece that's missing. So just like before, cross multiply, and you have 4S is equal to 3 pi times 40. 3 times 40 is 120 pi centimeters. I want to solve for S, so you divide by 4. 120 divided by 4 would give you 30. So S is 30 pi centimeters. So you just found how long that arc is cut off by the angle. All right, well, getting back to kind of like what the definition of an angle is in radians, it's your arc length divided by your radius. Your angle is theta. Sorry, I'm hesitating. S divided by R, so you have 10 feet. I'm going to use the little notation to indicate the feet, by 22 feet. These units will cancel, so you have 10 over 22. This reduces to 5 over 11. That is the angle. Notice that you don't put degrees with it, because this is an angle measured in radians. They're unitless. That's why I've been telling you guys, if you want to write 45 degrees, you need to put the degree symbol. Because now if you write 45 without any symbol there, it means 45 radians, because radians are unitless. Okay, let's try this one. I want to use theta equals S over R. Theta is 225 degrees. Whoa, wait a minute. You guys, this is the definition for radians. You can't fill degrees into it. So once I show you guys how to convert from degrees into radians, we'll come back and we can finish this one. Okay, using the definition S over R, what you'd like to do, remember this is the unit circle, the radius is 1 unit. All right? I'd like to be able to find out what all these angles are in radians. One place to start is, if I were to take, I would need to find out what the equivalent to 360 degrees is. So in other words, I'm going to find out what the angle is spun all the way around. Well, the reason I'm using that is because S is easy to find then. That would just be the circumference of this circle. Circumference is 2 pi r. So that would be the length of your arc. Over r. Look, r's cancel out. Whatever the radius is, even if the radius wasn't 1, which it is on the unit circle, all the way around is the same as 2 pi. 2 pi radians. Okay? These are equivalent. All right, well, let's keep going with it. What if you wanted halfway around? Well, if all the way around is 2 pi, halfway around has to be half of that. So 0 pi, another pi would give you 2 pi, so that's the same as 360. Okay, that's the same as 180. Well, half of that, up here at 90 degrees. That's pi over 2. Okay, 30 degrees is here. What part, what fraction, or what would you multiply 30 by to get 180 degrees? Or how many 30s fit into 180? Well, that's 6. So 30 degrees is 1/6 of 180 degrees. 180 degrees is pi, so 30 is the same as pi over 6. I can use that same argument, and 45 degrees is what fraction or part of 180 degrees? Or what would you multiply 45 by to get 180? Well, 45 and 45 make 90, and 45 make 135, and 45 make 180. So you'd multiply it by 4. So 45 is 1/4 of pi. Okay, 60 degrees. 60, 120, 180. So it's 1/3. So that's pi over 3. With this information, I can get the entire rest of the unit circle. All right, here goes. Remember those rectangles I drew for you earlier? Oops, oh my goodness, what happened there? I don't know. Those rectangles where we were looking at that everything on this rectangle has to have the same coordinate, well, all of these have to be a multiple of 30 degrees. Or, said this way, a multiple of pi over 6. Let me try, and same thing with this one, as long as I'm going on that tangent. Everything here has to be a multiple of pi over 4. And then all these have to be multiples of pi over 3. Whoa, my goodness. My straight lines are less than straight. Okay. Let me show you how to work that through. This is one way to do it. I'm going to count by 30. So you guys have to follow this. 30, 60, 90, 120, 150, 180, 210, 240, 270, 300, and 330. I'm just going to do that with pi over 6. That's 1 pi over 6. That's 2 pi over 6. That's 3, 4, 5, 6, 7, 8, 9, 10, and 11. And perhaps to check, that would make 12 pi over 6, which we've already talked about. That's the same as 2 pi. Okay? That's all the angles except the 45s. Here's how you can get the 45s. You have to memorize that's pi over 4. Now count pi over 4. That's 1 pi over 4. This would make 2. This would make 3. That's a 4. That would make 4 pi over 4. Oh, that's a 4 again. That next one is 5. 5 pi over 4. This would make 6. Oops, I was going to write a... Whew. Okay, there we go. And then this one, next one would make 7. And if you wanted to check that you're back at the right place, that's 8 pi over 4, which again is back to 2 pi. So now you get all the angles. Now the downside of doing it this way is now you have to go back and reduce all these suckers. So that's going to be pi over 3. This one's going to be 2 pi over 3. This is just going to be pi. This one is going to be 4 pi over 3. This is either one, 3 pi over 2. This one would be 5 pi over 3. Okay? But what you should notice is check out the pi over 6, 5 pi over 6, 7 pi over 6, 11 pi over 6. These all have 6 as the denominator. All the red ones here that are on this square all have pi over 4. 4 is the denominator. And then what's left is pi over 3. All right, let me try another way to show it to you, that you don't have to reduce. Start with pi, so there's pi, 2 pi. I suppose it's also 0. 0, pi, 2 pi. This is pi over 2, because it's half of that. Okay, now count it. 1 pi over 2, 2 pi over 2, 3 pi over 2. Okay, so I just did that to reference you back. There, we got that one. Now go to this one. You have to memorize that's pi over 3. And you have to know your multiples of 60 now. 1 pi over 2, 2 pi over 2, 3. 1 pi over 3, 2 pi over 3, 3 pi over 3. This next one is 4. This next one would make 5. Then go to your 45s. So that's going to be pi over 4, 1 pi over 4, 2, 3, 4, 5, 6, 7, and there you go. Now what's left is the pi over 3s. Sorry, pi over 6. So 30 degrees, pi over 6. There's 1, 2, 3, 4, 5, 6 pi over 6, 7, 8, 9, 10, 11. And all I was doing was counting by multiples of 30. 30, 60, 90, 120, 150, so on. 1, 2, 3, 4, 5 times 30 is 150. I'm just doing multiples of it. And that gets you all of them. Okay, again, give a quick look. All of these are divided by 6. All of those are divided by 4. All of these are divided by 3. Oops, who wrote that one? Little crazy goober. 5 pi over 3. Why didn't somebody speak up and tell me that? Good gravy. Okay, it's 5 pi over 3. 4 pi over 3, 5 pi over 3. Who wrote the 6? Man, you guys are just seeing if I'm paying attention. All right. One other way to reference this is by referencing pi. You guys know that this is 30 degrees, and you know that 30 degrees is pi over 6. If I'm dealing with 6's, doesn't this have to be 6 pi over 6, so it reduces to pi? We'll cut one off. 5 pi over 6. Add one on. 7. You can go to 2 pi and do the same thing. 2 pi would be the same as 12 pi over 6. Cut one off. 11. You can do it with 45s. So that's pi over 4. This would be 4 pi over 4. Cut one off. 3. Add one on. 5. Do the same thing for 60 degrees. So that's pi over 3. So this would be 3 pi over 3. Cut one off. 2 pi over 3. Cut this angle off. So add it on. So that would be 4 pi over 3. And you can do the same thing here, because this would be 6 pi over 3. Cut one off. And who wrote the 6 down there again? Good gravy. 3. 6 pi over 3, cut one off, and you got 5. This would be 8 pi over 4, cut one off, and you get 7. Okay? So I'm doing that by referencing the corners. Oh, pi over 2, 2 pi over 2, 3 pi over 2. Sorry about that, I forgot those. I'm referencing the corners. Okay? Converting. When you guys convert something, you need to multiply by something that's worth 1. Looking back here, the easiest one, equivalence you could use, this angle is pi, it's also the same as 180. I could use any equivalence. I could use this pair, I could use any pair I wanted. This is the most compact. You don't have a fraction and a fraction. What I mean by that is here. I need to multiply it by something worth 1. The top has to be the same as the bottom. I want degrees. What you want goes on the top. What I want to cancel out goes on the bottom. The pi's will cancel, and you get 180 over 9. When you multiply fractions, then you just go straight across. You cross cancel, but you don't cross multiply. And that's 20 degrees. To convert this one, I want to get rid of radians, so that goes on the bottom. I want degrees. 7 is not going to go into 180. 2 times 180 is 360 over 7. And you're done. You don't have to type that in. You don't have to get a decimal for it. What makes it radians isn't that it has a pi. What makes it radians is there's no degree symbol. So if I want to get rid of it, radians, and get degrees, I'm still multiplying by the same thing that's worth 1. The top is the same size as the bottom. There isn't going to be a whole lot that reduces here. If you guys want to, you can bring up a calculator and you guys can type the thing in a calculator. Just don't type the pi into it. Let pi be pi. So I have 18 times 180 divided by 5. And if, okay, so 648 divided by pi. Just let pi be pi. That's what I was saying. Don't evaluate it. I want the exact answer. That's what I say. 48 degrees over pi. It's fine. Just leave it alone. If I only want to get radians, then degrees has to go on the bottom and pi goes on top. Degrees cancel. So I've got 25 pi over 180. If you guys want to know what that is reduced, grab your calculator and just type in, don't type in the pi, 25 divided by 180, enter, gives you some decimal, go math, enter, and it gives you 536 pi. So your answer would be 5 pi over 36. Okay, this one, same thing, multiply by this. So I've got 127, the degrees cancel. Pi over 180. I don't think that's going to reduce, but you can try it. 127 divided by 180. And math, enter. Nope, doesn't reduce, so that's done. Times pi over 180 equals, the degrees cancel. So you get 312 pi over 180. Let's see if that one reduces. I think it's going to give us something. 312 divided by 180. Math, enter. So 26 pi over 15 would be your answer. 26 pi over 15. Okay? Now let's go back to a previous screen when we talked about theta is equal to S over R. I couldn't use 225. I have to convert 225 into radians before I can use it. I want radians, degrees on the bottom, degrees cancel. So I've got 225 pi over 180. I need to reduce it. Don't type the pi in. 1 1/4. So that would be 5/4. 5 pi over 4. So theta equals S over R. Theta, instead of this, it's 5 pi over 4. Because it's the definition of radians, I have to fill in a radian angle. An angle measured in radians equals S, 6 inches, over R. Cross multiply. And I've got 5 pi R is equal to 24 inches. Divide by 5 pi, and you're done. Don't evaluate this. Don't type it in your calculator. That would be the exact measurement. If I said round your answer, you'd round it, but you type it in and round it. But I'm not saying that. Just give me the exact answer, so you're done. Okay? Now, you guys had the definition of sine the other day. It's on the unit circle. It's your y value. Cosine is your x. Tangent is your y over your x. Filling this out is no different than what you guys did before. You're just using your angle now in radians. So let's say 2 pi over 3. The coordinate at 2 pi over 3, that's the same as 120 degrees. 2 pi over 3 would be -1/2 square root of 3 over 2. So, what's your y value? Square root of 3 over 2. What's your x value? 1/2. So, what's the reciprocal of this? 2 over the square root of 3, and then you rationalize it, you get 2 square roots of 3 over 3. What's the reciprocal of half? 2. Tangent is your y over x, so square root of 3 over 2 over a half multiplied by its reciprocal, so I get the square root of 3. Cotangent's the reciprocal, so I get 1 over the square root of 3, rationalize it, square root of 3 over 3. Okay, so don't forget everything you guys did on the sheet before. Now your homework is to do it with radians to practice the radians. Okay, thanks for your time.